f of x is the square root of x, and g of x is x minus 2. State the domain and range for f of x and g of x. So again, it's not a bad idea to just quickly sketch a graph of these. I will do f of x in blue. So from your transformations unit, you can quickly graph that function. And I'll do g of x, x minus 2 in red. Have a y-intercept of negative 2, a slope of 1. Actually, this is a little bit off. Let's just draw a really big dot right here. Because they both go through 4, 2. So the red one, we could have our y-intercept at 0, negative 2. We could have our x-intercept at 2, 0. And we also have, hard to miss that point, 4, 2. So those are our two graphs. What do we want to do in B? Well, okay, first of all, for the blue graph, in A, the blue graph's domain is x is bigger than or equal to 0, and its range is y is bigger than or equal to 0. And our red graph, the domain is everything, and the range is everything. And this is a dividing one. Dividing ones have that extra bit of problems because you're not allowed to divide by 0. Which is our function on the bottom? G of x. The red graph is the one on the bottom. Do we have any places where the red graph is equal to 0? Yes. The red graph is equal to 0 at 2. So I'm going to redraw my axes here just so that my original equation doesn't get too busy. We've learned already that in order to graph a new function, combining functions, adding, subtracting, multiplying, or dividing, you have to have numbers in both. So my domain, since my domain of my blue one is x is bigger than or equal to 0, when I divide these graphs, it's also going to be bigger than or equal to 0. Okay? But with dividing, we have the added problem that you're not allowed to divide by 0. So in this case, the red graph is equal to 0 at 2. So when we get to 2, we would have an asymptote. So now let's look at a couple of things that we know on this graph. Okay? When the blue graph is 0, 0 divided by negative 2, you would get 0. If you chose another point here, 1, 1, and here I have 1, negative 1. What is 1 divided by negative 1? Negative 1. So on my green graph, I would have 1, negative 1. Will I have any more x-intercepts? In order to have an x-intercept on my green graph, my blue graph has to be 0. My blue graph is only 0 once. So from this, I know my green graph has to go down towards that asymptote. If the blue graph is 0 and the red graph is negative 2, 0 divided by negative 2 would be 0. So I will only have x-intercepts where my blue graph has an x-intercept, which makes sense because the only place a fraction is equal to 0 is if your numerator is equal to 0. If we look at this point, 4, 2, The y value is 2, the y value is 2. On my green graph, 2 divided by 2 is 1. I will have 4, 1. Okay, if it's going towards the asymptote, can you see that it has to go up this way? Okay? In this direction, this is where things get tricky with points. What should I do here? I know I don't have any more x-intercepts. Should this graph go up again, or should it flatten out? How do we know? How do I know that it flattens out and eventually there will be an asymptote at y equals 0? Well, one of the ways you can do that is by looking at the explicit equation. Okay? And in B it says, write the explicit equation. So my explicit equation for q of x would be, it is blue square root of x divided by x plus 2. X minus 2, sorry. I'll keep the colors the same, because it was my blue graph divided by my red graph. Can you see that if you changed, so a lot of ideas start to come together. If I change x to the 1/2 over x minus 2, and if we think back to chapter 2 in our rational functions, we never had to graph ones like this in our rational functions unit because we always had polynomial divided by polynomial. But we can use some of the ideas we learned in that unit to help us find out that there's an asymptote here. What did we do when the degree was bigger in your denominator? We always had an asymptote at y equals 0. And if I change the square root to x to the 1/2, on the bottom my degree is 1, on the top my degree is 1/2. I have a bigger degree in my denominator. I'm going to have an asymptote at y equals 0. Because the idea is, as x gets really, really big, the square root of x is smaller than x. And when you divide by a bigger number, you get closer and closer to 0. So looking at the equation, it's not easy to determine the domain and range. We needed the graph, and looking at the graph, this one's a little bit crazy. Because the domain is x is bigger than or equal to 0, comma, x can't equal 2.
So we determined that it goes towards, like, down because of the asymptote?
We determine that it goes down and to the right because there is an asymptote at y equals 0, and we know there is an asymptote by looking at the degrees of the functions. Looking just at the graphs, okay, looking at the red graph and the blue graph, can you see the red graph is getting bigger faster than the blue graph is getting bigger? As x goes to infinity, the y values of the red graph are going up faster than the y values of the blue graph. And so when I take the blue number is always going to be less than the red number. And when you divide by a bigger number, you're going to be less than 1. And as you keep on going, the red number keeps getting bigger, so you keep getting smaller and smaller. It will eventually approach 0. Okay? But once we've graphed our function, domain x is bigger than or equal to 0, x can equal 0. And here's the tricky one. What's our range? It's everything. So normally you would probably want to say y can't equal 0, right? Because there's an asymptote. But we do have the point 0 right there, so that includes it. And then y is everything. So if you take your highlighter out right at the top of this page, just because we did this with all of the other ones, highlight the normal notation and the not nice notation. So whenever you see not nice notation, whenever you see not nice notation, which is, well, that's even not nicer, f divided by g of 2, or you see it this way, f divided by g of 2, or maybe you even see it like that. Can you see how all of those would throw you off? They throw me off. I would take them and change them to be f of 2 divided by g of 2, or f of 2 divided by g of 2. Something that you can understand a little bit better. And in this case, what is f of 2? It's 2. What is g of 2? It's negative 1. So this would be 2 divided by negative 1, which is negative 2. And if we look at our graph, we have the point 2 comma negative 2. So the main thing when highlighting here is we just want to get used to that new notation, so that if you see notation like this, you switch it to a notation that you're used to, regular function notation, and then you'll be able to solve for it no problem.